How are we doing, everyone? So we're going to quickly go through how to graph a quadratic in Sheets. All right, so I got all my data in, let's get ready to go. So we're going to highlight everything here. We're going to insert chart, see what it looks like. Ooh, not terrible. But of course we don't like that this is a line chart. So under setup, which is right there for you, chart type, go right here to scatter. We want those dots, all right? Looks good now. Is the title right? Yeah, I think so. Displacement versus time, displacement on the Y, time on the X. Just double check your values, make sure they're on the right axes. But yeah, we look pretty good there. So we don't have to touch anything else there. Let's go to customize real quick. Just touch up some stuff. If you want to change the colors and stuff like that, yeah, you can do that. But let's go to series. That's where I want to be right now. So under series, there's my displacement data. I can change the colors, all that good stuff. Change the shape if you want. I want to add a trend line. This is really what I want to talk about. Notice how this trend line looks terrible. All right, so clearly this is not a linear function. All right, so let's check out the other ones we got. We got exponential. How does that look? Not bad. Let's see, we got polynomial. That'll end up being one we choose. Logarithmic, terrible. Power series, that's pretty good. I don't really know what power series is though, so let's kind of skip that. Moving average, not terrible. But we are going to choose polynomial. That will be the fit we use as a second degree polynomial. I don't even know if we have third degree polynomials in this class, but if you did have one in a math class or something, that's where it would be. Now we're going to label this using the equation. All right, don't put on the R² value, you don't need it. Let's look, is there anything else we need? No, overall pretty good. Now, one really cool thing about this graph is that this is actually the distance equation. If you recall, there's an equation, I'll write it out here, D equals E initial times time plus 0.5 times A times T squared. All right. The equation should look a little familiar from stuff you did in class. You may have written it a little differently, but it should look something like that. Now, one really cool thing here is that if you look at this equation here, this coefficient in front of the x, that's your initial velocity. So our initial velocity in this case, even though it should have been 0, is equal to 0.0432 meters per second. But that's pretty small. This first term here is actually our initial position, but basically 0 here. We're talking 2.5 millimeters. I'll take that any day. And this number right here in front of the x squared, that is actually half of the acceleration. So if you multiply that number by 2, you get your acceleration. So A equals, let's see, that number multiplied by 2. Let's say I didn't know how to do that. Equals 4.82 times 2. That did it for me. 9.64. Okay, 9.64 meters per second squared. Not too shabby considering the accepted value is 9.8 meters per second squared. All right, so there's how we do some quadratic stuff. Really cool way to find the acceleration, to find the initial velocity. We'll definitely be using this in the future, so make sure you know this.